Why?
Because they're never right.
Oh, because they're
That
never
was good.
right.
I didn't even think of how much.
I said a two. When does a joke become a dad joke? I think you said two.
All right, hey, we can do these at the end of class, but now we're going to do another math problem. Like, we're going to show the solution, then we're going to do another problem. If you have your answer of 7 years, and you have work to support it and would like to share it, I realize now I need to do random cards for this.
No.
What? Guys, otherwise it's like I'm picking favorites. You're going to say no, but then if it's your card, you're going to be happy that I'm doing random cards.
I'm good at random cards.
You're in here. Yes, you have.
I feel like I never.
Anna, do you have work you want to share? That's fine. Walter? Connor? Yeah? Whoa! Hey, we're in here to support each other. None of that. So you got an answer of 7?
Yeah.
Jake, be cool or be elsewhere. Ooh, so we used a table. Love it. Start at 19, start at 5, growth of 3. We're growing 3 the whole time. Growth of 1 over on this side. Love it. Tables are one way to solve problems like this. Thank you very much. Colin. Okay, is that a yes? Amelia? I know. I'm taking multiple people because I want to see multiple ways to solve this. Ooh, this is different. So, Colin decided to make a graph. We're going to zoom in to see it a little bit better. So, he started the cat here and grew by 1. Started the bunny here and grew by too much. And 3 pounds a year, that seems like a lot. And as long as we've drawn it correctly, we can see that we intersect 7 years in at, it looks like 26 pounds. And that, I think that agrees with what Connor had showed us.
You can show them my demented bunny.
Ooh, demented bunny.
Yeah.
So, what did we do? Oh, okay, so as long as we keep the amount of additions the same. So Amelia was showing if we add 1 year, 2 year, 3 year, 4 year, 5 year, 6 year, 7 years worth, we get to both being 26. And then she also defended it with the math of if we gained 3 pounds and multiplied that by 7. Love it. This is awesome. Max K, last one. It's well for the moment, guys. I've got a whole deck of cards.
Okay, so first I found the rule, and then what I did is I put the rule in both the rules into my calculator, and then I counted the x-axis.
Here's what Max did, but I'm going to show it slightly differently. Here's what Max did. No, seriously, this is what Max did. But because not all of us have one of these calculators, by the end of class, you're going to know how to use Desmos as your best friend. Guys, I'm serious. It saves you time. It saves you energy. This is awesome. I could not have paid you guys to have given me a better 4 different solutions. Do you want to show yours now? I already called your name, so we'll let Anna go because I already called her name. Her card is in the the stack of people that got called. Ooh, I gotta turn the camera back on. Sure. So Anna did slightly the same thing as Max, she says, except for, of course, because she's Anna, she has the beautiful header to her paper. And she went ahead and identified y-intercept and slope. So I hadn't seen that written on anyone else's paper, right? Talking about the y-intercept and the slope. So she wrote out the equations, starting at 5, adding 3 pounds every year. Starting at 19, adding just 1 pound per year. Ooh, wait, what did you do down here?
I did the most magical. I don't know, but I was working on Desmos and I discovered it and then I used it.
It was working on Desmos. I discovered it and then I used it. I love it. I saw it work. I realized it worked. I use it now. Awesome. That's pretty much life, right? Like, oh, this works. So let's try this. Thank you so much, Anna. At Post Falls High School in Idaho, there are 1,160 students and is growing by 22 students each year. At Richmond High, in Indiana, there are 1,900 students, and it's actually having a shrinking population, losing 15 students each year. Obviously, in the past few years, Worthington's been growing, right? So, without graphing, sorry, Colin, without graphing, and I'm going to go ahead and say, sorry, Max, but we can't graph in the calculator either since it says without graphing. No tables.
What?
Sorry. And Amelia's like offended. She's like, what? No tables.
I said that.
Oh, well, sorry, Brenda's offended. When I looked over, Amelia was like holding her face like I can't believe it. I want you to try to take the method we just saw from Anna's paper. Guys, I did not plan this, Scout's honor, but this is what I'm supposed to teach you today. Exactly what Anna just showed us is what I'm supposed to teach you. It's way more meaningful when it comes from you guys.
What was Anna's message?
I saw it on Desmos.
So, can I borrow this again?
Oh, yeah.
I've seen what she can do. Anna's just a wizard. You're a wizard.
So, here's what Anna did. Guys, by the way, grading Anna's paper gives me a slight amount of anxiety because everything looks so nice, and I'm like, my check marks look really sloppy compared to her handwriting. Like, I'm not joking. When I grade her paper, I feel bad. Because, look at how perfect everything is, and I'm just like, boom, 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 check, check. So, Anna set up an equation for the bunny, and equation for the kitty, and we asked, when will they be equal? So what she did was she said, okay, make them equal. Just set them equal. And then she did that whole fancy pants magic that we call algebra to get just a single x isolated on one side. Try that with postfalls and Richmond. You can use your calculators to, do computations, but you cannot, make graphs in them. I will return momentarily. I hope the copy machine did not break in the middle of running my copies.
Her method was she found out about it before we were supposed to learn about it.
Doesn't that sound good?
Yeah, lecture. How do you calculate?
You can pretty much.
I need a calculator. Hey.
By the way, when I do the thing that teachers aren't supposed to do and I leave the room, we're recording, right? So if stuff goes down, I can just always go back to the tape. Which there's no tape anymore. Nothing records on tape. What Anna just showed us is called the equal values method. Yes, I think the person in charge of creative names was out that day. The equal values method. Meaning, you put two values equal. What happened to what?
What happens to names like the butt cheeses first?
Yeah, well, that's because I'm the creative namer around here. This is the technical, name of the thing you should know. Associative property is the real name, right?
We don't talk about that one.
I mean, we can call this the Chubby Bunny Kitty method if you want.
Yes! Yes!
So, our Chubby Bunny Kitty method says, take the Chubby Bunny, set it equal to the Chubby Kitty, and solve. Now, what Anna... Hold up. Huh. Ironic. You're taking it too
I
far.
want to actually have this one as the new method, because saying the equal values method is boring.
We're talking to CPN.
So, cross out Chubby Bunny Kitty method. I don't care what you want to call it. But here's the one thing that I don't think Anna had kept going in her work. So even though I could probably go ahead and pay her and let her teach my class and just go ahead and retire, my retirement doesn't have enough money in it yet, so I should probably hang on to my job. Once we solve for the x, we can then solve for the y by plugging that x value into either of the equations that we have. So guys, seriously, on your notes, if you want to call this the Chubby Bunny Kitty method, I don't care. But what we want to write is like, what we did was we set bunny equal to kitty. How many math teachers teach using bunny and kitty equal to each other? Then we found out the years, right? Now this is not our Chubby Bunny Kitty, but if we're going to call it the Chubby Bunny Kitty method, when we found out what the x was, we could plug the x back into bunny, or we could plug the x back into kitty. It doesn't matter. Regardless of which equation you plug it into, you should get the same y. And if you want to verify that you did it right, plug it into both. Because if you plug it into both, you should get the same answer. So, Renald, do you like your work enough to share it with the class? Actually, here, I'll give you guys the answer so you can check it first. Let me grab my book, because like I said, I taught foundations, and that always throws me off. Is it x equals 20?
Yes.
We got x equals 20? Okay, well, I guess it's x equals 20.
I did the Chubby Bunny. They have 1,660 students that year.
Close. I think you're off by a slight power or something. You're off by a very small amount, but you have one number in there that shouldn't be. Renard, do you like your work enough to share it? You don't have to. You can say pass. Aiden, Russell. Oh, well, Summer isn't here anymore. I don't have to specify.
I don't really
Heartbreak. Do you want to share?
You know what? Still specify for him.
Right, just because. Pay a little homage to...
That doesn't mean much.
Do you want to share? Did you get 20 years and 1,600? You don't even have to have the y solved out yet, really, but... Okay, do you want to share that? I'm just trying to give you guys opportunity to share your work with each other because I'm trying to brainwash you into doing math with each other. Can I fold your paper?
Yeah.
All right, so Aiden said... Actually, I probably don't need to. Aiden said post falls, starts at 1160, adds 22 each year. Now, guys, this is not in y equals mx plus b, but it's in b plus mx, which makes more sense in this situation. Right? We started at... And then we're adding. You don't have to write it with the mx first. You can have the mx second. So then Richmond, he sets them equal to each other. Guys, at this point, remember, we have 4 options here. Look up at the board real quick. You could add 15x. You could subtract 1900. You could subtract 22x. Or you could subtract 1160. All of those would be right options. Aiden took the option saying, I'm going to get rid of the smaller of the values and keep this value positive. So when he did that subtraction, he got 740. Then he dealt with the variables and he took the 15x off of this side because now our constant is over here. Get rid of that variable. Conveniently, that made us have a positive 37x equal to a positive number. Nice to work with. We do the division by the coefficient, if we're trying to keep incorporating that vocab, and we get x is 20. Then we can plug it back in. Can I write on this? Yeah. We can plug it back into either high school. So grab one of your high school equations. I like to use the one that is positive versus net. Like positive is just easier to work with. And we do 1160 plus 22. But now we know our x is 20. And when you solve that, you should get 1,600 students. Questions? Questions? Ready to do another and flex how good you are at this? If you're currently working on your homework, please stop. We're practicing this together to make our mistakes together. You have a question. Okay, Brenda.
May we brag to the 7th graders that we have a chubby bunny, chubby kitty method?
You are 7th graders.
They would practice the peasants.
I don't like saying chubby twice. I just kind of like calling it the chubby bunny kitty method, but it just flows a little better.
The chubby bunny kitty method is
Like it's funny how good that was.
I just think
It's funny.
the chubby bunny.
All right, last problem I want to do. Last problem I want to do. And legit, I might bring my ficus tree in here because we don't have space in my house right now. But at home, I have a ficus tree. Let's say that we bring it in. It's about 6 feet tall when it's planted, and it grows 1.5 feet per year. That probably wouldn't work here because you shouldn't have a ficus outside in Ohio. It will freeze. But let's imagine that we're somewhere where that's okay. The other tree is an oak, and we actually, like we saw on a test earlier in the year, it's a seed. It's an acorn. It was in the ground. No, wait. Where is it?
Negative.
It's where?
Negative somewhere.
Hey, don't listen to me. Read what's on the board. What'd you say, Max?
0.
How? Where is it? What word indicated to you? No, I'm looking at you. I'm pointing at you, not the poster. What word made you think it's at 0?
Ground.
Guys, crazy thing about plants, like, plants just want to grow. I put 2 plants over in Mr. Cabillo's room that were growing from clippings. Like something that if it fell on the ground might have died, but might have, given the right circumstances, sent out roots and became a plant. An acorn on the ground, given the right circumstances, can root and grow. But if it's sitting on the ground, we would call that 0. So your acorn tree is going to grow 2 feet per year. And how many years will the acorn be the same height? The acorn tree, the oak tree, sorry. It has acorns. It is an oak tree. When will they be the same height? How many years and at what height? So I need to give you a couple minutes to be able to do both. How many years and at what height? The oak tree starts at 0 because it is starting from on the ground. Huh? This is what I just said, everything I just said. Given the right circumstances, a seed could literally just on the ground put out roots and start growing. And actually, guys, that happens in probably all of your yards. You ever see those helicopter things that come down? Those start sprouting trees. I dug up 3 of them this year, and I'm trying to keep them and like turn them into actual trees. Yeah, like they hit the ground, they get moist and like warm, and that's how seeds just do their thing. Yeah. I guess you can solve this however you want. I mean, I agree. I would go Chubby Bunny Kitty method, but
Oh, I started making a chubby bunny method. Duh.
I guess. How many pounds?
that's the wrong thing. A little bit of solving math music for you.
And it's 30 pounds. 'Cause I got the time.
The tree is 30 pounds.
I got the time of it. Probably 30 feet tall.
I'm trying to go over here now. How do I use the height of the chubby bunny kitty?
So we would just set both equations equal to each other and solve for the time. Then once we know the time, we can plug it into either of them.
Okay.
But if you want to be real certain, plug it into both, and they should equal each other.
Okay.
Right? So if we're saying that's when their height is the same height.
Oh yeah. Okay.
Sounds like
It is not. It's like a weird band from Europe called Lemon Jelly.
It sounds like Mickey Mouse Clubhouse. And trust me, my sister watches it every day. It definitely sounds like Mickey Mouse Clubhouse.
6 feet tall. Huh?
I just get 2.3.
What?
I just 2.3.
2.2.3. 2.3. Like, what?
The, yeah. The one that
Oh, why did I not drop it? Did I not drop it? Are you sure there's not one like in between Grant or? I mean, I will give you one. I just thought I dropped enough back there. What was confusing me is you weren't saying 5. You were just saying 2.3. Yeah, I wrote on this. I mean, you don't drop it by accident. You did my stuff in your mind, just not realizing. Remember, the Chubby Bunny Kitty method only works because they're both talking about the same thing. Like how chubby the kitty and bunny are, or how tall both trees are. If one is talking about height and one is talking about weight, that wouldn't really work. Then we're all going to do our first homework problem together to practice doing this graphing. Let's use some random cards to have you guys help me through this. Grant, what would you do first with what I have written up there? I forgot to write equals h over here also, but this is why this works. They're both equal to h. We're setting them equal to each other. Grant, what would you do first? There is a best option, but there are multiple options. And you can always pass. So this is easier to look at. I get rid of these. Because they're both equal to h, but we don't really care about that. Go ahead.
Minus 1.5x.
Yeah, take away the smaller x. Then we got 6 is equal to... How do I turn a 0.5x into a 1x? Times 2. Well, we could, but it's real complicated, so...
Is it? Yes.
I mean, it does the same thing, but thinking through it is complicated.
I just know what happened. Well, I don't want to use my calculator.
So the trees are 12 feet tall, right? No. Spencer. Sorry, you raised your hand. How? Tell me what to do. This is years. So guys, when you have a situation like this, there's an easier equation. The 2x. Plug it in here. Or, I mean, you can plug it in over there, you'll get the same thing. But guys, come on. If we're going to choose the... I don't know what my computer's doing, but it doesn't want to agree with me today. Plug it in here. 2 times 12. 24 feet is how tall they would be. All right, the last one we're going to do today is actually the first question on your homework. What? Well, 12 times 1.5 is a 12 and another half of 12. So what? So that's 18 plus another 6, 24. It would also equal 24. Now hold up. This, hey, 48 is the one that I think we should probably do. So, 48, I would do some thinking first. 48, I would do some thinking before you draw your graphs, or before you draw your axes. Start talking with your team, and you can talk about 47 if you want, but I think 48 would be better for us to do right now. We're going to graph, right? Like Colin showed us earlier, we're going to graph these lines to find where they intersect. But we need to be a little strategic about, like, if I only allow a first quadrant graph, right, if I only look at the top right quadrant, I may not find where they intersect. So we should probably draw a graph that includes multiple quadrants, like maybe even all 4. Hint, hint, nudge, nudge. Talk with your team. We'll talk about this together in a minute. Well, in like a few minutes, probably. I like people that are discussing the scale with each other, saying, what scale do you think we should use?
I don't like how you made it Now you said that.
Yeah, for the Y. But for the X, you don't need to.
Yeah, so I'm going to go ahead and give an opinion here, because I hear the conversation and I like it. Yeah. Remember, the point of graphing is to show as much as we can, but not be excessive, because we want it to be detailed. Right? So some of you on your test, and actually there's a couple of you that I put like see me about your graph, you make good graphs, but it's hard to see it because you scaled by like 4s or 5s, or even a couple of people scaled by 10s. We want to scale as small as we can. So those people saying just go by 2 or 5 or because that's going to be easy, it's not actually easy because it's harder to accurately place the points. So when I go to graph this and I want to intentionally graph all 4 quadrants, I make sure that my origin point is somewhere in the middle of my graph space. And guys, again, like, I made these homeworks to try to make it easier for you to have this space, but if you turn in a paper and you didn't graph the lines, it's real easy for me to look at it and be like, nope, didn't do what we asked. I would go by 1s if you're able to, because then it makes the y-intercept and the slope easier to think about. I'm going to color code these things. So y equals 2x minus 3. Where do I start? Jake. Hey, Jake, your card came up. Where do I start in the 2x minus 3?
At -3.
At -3, because that is our y-intercept.
0, -3.
Ooh, being even more specific, 0, -3. Then, Jake, you want to go ahead and tell me how I move?
You go up 2 and over 1.
Up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. Guys, don't just do 2 of these and then use your ruler, because it's real easy for us to mess up using our ruler. So I would do a bunch and then do your ruler. Right? Do a bunch and then do your ruler. All your points should line up on your ruler, or you made a mistake somewhere.
It's your problem, not ours.
Well, it's your problem because it's on your paper and it's your problem to solve.
That's why I didn't put the Y in the bunch. I like it.
So then, Max Wright, where do I start for this next equation and how do I move?
So I just realized I did mine wrong.
Well, that's good to realize in here, right? Because this is the safe place to make the mistakes. You want me to skip you?
I made mine entirely positive.
Well, at least you're being positive. But, Jordan, how do I start? How do I move?
Wait, no, I can still answer.
Okay, Max, how do I start? How do I move?
By you roasting me.
What?
So you move. So wait.
I'm trying to figure out where to start. So ready.
This is not.
You want me to skip you?
What?
You want me to skip you?
Yeah.
Ah, I didn't mean to mark that there. Jordan.
You start at 0, 3.
Start at 3, the constant number, the thing not attached to the x. That's our y-intercept. How do I move?
Down 1. Down 1 and over 1.
Down 1 to the right 1. Oh, hey, look, I found my intersection point.
Give me a 2, 1. Wow.
So, guys, we got fortunate here that if we had just drawn a first quadrant, we would have seen it. But I need you to get in the habit of making 4 quadrant graphs. I need you to get in the habit of making 4-quadrant graphs. I also need us to get in the habit of keeping the scale as small as possible. I haven't marked any questions like wrong about this yet because we hadn't really talked about this, but we don't need to scale up unless we need to. Don't scale up unless something tells you to scale up. So if I needed my x to go out to 150, obviously that would change this situation. But all I needed to do was be able to see these lines, and since those numbers aren't very dramatic, I can just see these lines. Now, like I promised, before you get out of here, I'm going to show you how Desmos is your best friend. And not, like, I don't mean, like, the Desmos activities that I assign to you. I mean just using Desmos like a fancy pants calculator. So if you have between $100 and $150 or an older sibling, you might run out and grab one of these because now you realize we're doing graphing. You do not need to. Let me speak very clearly when I am not telling you to go buy one of these. You can if you want. They're great. They have colors. It's awesome. But the point of Desmos... Hey, I got like 2 minutes and I need to wrap this up. When Desmos started, their goal was to keep high school students from needing to buy one of these because they know they're expensive. So when I go to Desmos.com and I hit graphing calculator, they've tried to make this be able to do essentially everything that a graphing calculator can do. And we don't need much of the like in-depth stuff that the calculator does yet. What we need is just to be able to graph these lines. This is automatically assuming that I'm talking about y. So you don't have to type y equals, but you can if you want to. But if I want to graph 2x minus 3, 2x minus 3. Hey, look, 2x minus 3. Since I made it blue on my paper, I'm going to change it to blue. You long hold on it and you change it. If I want to change what the line looks like hold down the click. You can change what the line looks like. Then, negative x plus 3. But wait, I want to blow your mind. What if I wanted to look at a line and analyze, you know, Mr. Hudson keeps saying like y equals mx plus b. What the heck does m do and what the heck does b do? I'm going to turn these graphs off. This is the mx plus b line. What happens as b changes? Oh, the line goes up and down. And guys, this is actually harder to do on a TI calculator than it is on Desmos. Okay, so that's what the B does. What about when I change M? Oh, it changes the steepness.
Can you get to, you try and get to...
And then, if you really want to blow your mind and just like have to pick up the pieces, guys, the Desmos art contest, which I regret to tell you, you gotta be 13. I would not. So right here, if you go to Desmos.com, they're having their art contest again. Hold on, I wanted to show you one.
You have to be 13 by They're insane.
Hold on. Check this out. So here's the point of going and looking at other people's art and what they've done. You can learn how to graph these things by going down and looking at what they did. So if I want to look at the bubbles, I open up the drop down and I can turn on and off the parts of the bubbles. See this bubble over here? And it's moving because the sliders have a play button. So when we make a slider in Desmos, I can hit play and it moves on its own. So all right, that's everything for today. I just wanted to show you Desmos. You should have seen what we did. Jake, unnecessary, and it's recorded in my video.
Oh no.